Every year, like clockwork, trees put on one of the greatest natural shows on Earth. Green forests suddenly turn into explosions of red, orange, yellow, and gold. It looks magical, but it's actually the result of a very practical survival process happening inside every leaf. So what really causes this colorful transformation? Let's uncover the science behind autumn leaves right here on History of Simple Things. To understand fall colors, you first have to understand what leaves do all summer long. Leaves are basically solar-powered food factories. Inside each leaf are tiny structures called chloroplasts, which contain chlorophyll, the green pigment that helps plants absorb sunlight. Chlorophyll captures energy from the sun and uses it to turn carbon dioxide and water into sugar. That sugar feeds the tree and fuels its growth. Because chlorophyll is so important and so abundant, it completely dominates the leaf's color. Even though other pigments are present, all you see for most of the year is green. So in summer, your trees aren't just green for decoration. They're green because they're working full-time. Here's the surprising part. Many of the colors you see in fall were already in the leaves all summer. Yellow and orange pigments, called carotenoids, are always present. These are the same pigments that give carrots their color and corn its yellow hue. In leaves, carotenoids help protect the plant from too much sunlight and assist with photosynthesis. But during spring and summer, chlorophyll is so strong and constantly being replaced that it masks those yellow and orange pigments. Think of chlorophyll like a bright green spotlight. As long as it's on, you can't see the other colors behind it. So what actually starts the fall color process? It's not cold temperatures alone. The real trigger is shorter daylight. As days get shorter in late summer and early fall, trees sense the change in light. That change signals that winter is coming. Since winter means freezing temperatures and very little sunlight, it's no longer efficient for trees to keep producing food. So trees begin shutting down their food factories. They stop making new chlorophyll. As the existing chlorophyll breaks down and fades away, the green color disappears. And when the green fades, the hidden yellows and oranges finally become visible. That's why you start seeing golden birch trees and yellow aspens. They're showing colors that were always there. Yellow and orange are revealed. But what about bright reds and deep purples? Those colors usually come from pigments called anthocyanins. Unlike carotenoids, anthocyanins are not always present in leaves. Many trees actually make these pigments in the fall, right as chlorophyll is breaking down. Why would a tree create new pigments right before winter? Scientists believe anthocyanins may act like sunscreen for leaves. As chlorophyll disappears, leaves become more sensitive to bright light and cold temperatures. Red pigments may help protect leaf tissues and allow the tree to reabsorb valuable nutrients before the leaves fall. In other words, red leaves may help trees squeeze out every last bit of usefulness from their leaves before letting them go. Not all trees turn red, and that's not random. Tree species play a huge role. Maples, sweet gums, dogwoods, and sumacs are famous for their red and purple colors. Oaks and beeches often turn brown or reddish-brown. Birches and poplars usually go yellow. Genetics determines what pigments a tree can make and how it responds to changing light and temperature. That's why a forest in one region might explode with reds, while another area is mostly gold and brown, even if they're experiencing the same fall weather. Weather can make or break a fall foliage season. The brightest colors tend to happen when days are sunny and bright, nights are cool but not freezing, soil moisture is adequate, sunny days help leaves make sugar. Cool nights slow the movement of that sugar out of the leaves. When sugar builds up in the leaf, it can trigger the production of anthocyanins, leading to more reds and purples. But early frosts, drought, or long stretches of cloudy weather can dull the colors. A hard freeze can cause leaves to drop quickly before full color develops. So when people say, "This year's fall colors are amazing," they're really commenting on how perfectly the weather lined up. Color change is only half the story. The other big question is, why do leaves fall off at all? Leaves are great in summer, but in winter they become a problem. They lose water, get damaged by frost, and can weigh branches down with snow and ice, so trees prepare to drop them. At the base of each leaf stem, trees form a special layer of cells called the abscission layer. This layer slowly cuts off the flow of water and nutrients to the leaf. Eventually, the connection weakens so much that a strong breeze, or even gravity, can cause the leaf to fall. When the leaf drops, the tree seals the scar to prevent water loss and infection. It's a clean, controlled break. If deciduous trees drop their leaves, why don't pine trees and fir trees do the same? Evergreens have needles instead of broad leaves. Needles have thick, waxy coatings and antifreeze-like chemicals inside their cells. This helps them survive freezing temperatures without losing too much water. Because needles are built for winter, evergreens can keep photosynthesizing whenever conditions allow, even in cold weather. That's why pine trees stay green, while everything else turns colorful and bare. As beautiful as fall foliage is, it's not meant to be beautiful. It's a side effect of trees preparing for survival. By breaking down chlorophyll, reabsorbing nutrients, and sealing off leaves, trees conserve energy and protect themselves for winter. The colors are just the visual evidence of that process. In a way, autumn leaves are a tree's way of cleaning house before the cold arrives. Not every part of the world gets dramatic fall colors. Tropical regions have less seasonal change in daylight, so many trees don't go through the same shutdown cycle. In colder regions with strong seasonal shifts, fall colors are much more intense. That's why places like Japan, New England, and parts of Europe are famous for autumn foliage. They have the perfect mix of tree species and seasonal light changes. So when you see a red maple or a golden forest, you're watching millions of tiny biological decisions happening at once. Each leaf is responding to light, temperature, sugar levels, and internal chemistry. What looks like a simple color change is actually a complex, carefully timed survival process that's been refined over millions of years. Autumn isn't just a season. It's a massive, coordinated shutdown and recycling operation, wrapped in some of the most beautiful colors nature has to offer. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.